Hello guys, today in this video we will learn about von Neumann architecture. So the objectives of today's video are to understand the origins of non-Neumann architecture, understand von Neumann architecture, understand its components and functionalities, and also to be aware of the architectures. So the first question is, so what is an architecture? An architecture is a complex or careful design of a structure of something, fixed programs. These were designed to do very specific operations. A calculator is an example of a fixed program computer. It can do basic mathematics, but it cannot be used as a word processor or a gaming console. Changing the program of a fixed program machine requires rewiring and reconstructing or redesigning the machine. It could take 3 weeks to set up a program on ENIAC and get it working.
So now let's see what are the stored programs. A stored program computer is one that stores program instructions in electronic memory. Therefore, it is easily reprogrammable. Von Neumann is a stored program architecture, also known as Princeton architecture, introduced by John von Neumann. And of course, it is named after John von Neumann itself. A Hungarian-American mathematician, physicist, and a computer scientist, John von Neumann. So here you can see the basic structure of the von Neumann architecture. There is an input device. The input devices sends the instructions or data to the central processing unit. The central processing unit, that is CPU, consists of a control unit, arithmetic logic unit, and registers. And this data is passed and received from the memory unit, and then it is given to the output devices. Now let's see von Neumann architecture. The basic concept behind the von Neumann architecture is the ability to store program instructions in memory along with the data on which those instructions operate. The von Neumann architecture describes a general framework or structure that a computer's hardware, programming, and data should follow. Even all the most modern computers and mobile devices are designed based on this fundamental concept. It has three basic components: input output interfaces, central processing unit, that is CPU, and memory. Buses are denoted by the arrows that carries the data around and the addresses around.
Now let's see input and output interfaces. The input and output interfaces allow the computer memory to receive information and send data to output device. Allow the computer to communicate to the user and to secondary storage device like disk and tape drive. Now central processing unit considered can be considered the heart of the computing system. Include three main components: control unit, arithmetic logic unit, registers. CPU control unit are responsible for decoding the instruction and controlling how data move around the computer system. The execution of each instruction is determined by sequence of control signal produced by the control unit.
So let's move to arithmetic logic unit. Carries out the calculation and logical decision required by the program and instruction. Moving on, the input to an ALU or the data to be operated on, called operands, and opcode, indicating the operation to be performed. The ALU's output is the result of the performed operation. So let's move with register. Registers are the memory location with specific purposes. Moving to the first point, accumulator. Accumulator stores the result of the calculation made by the ALU temporary. Program counter keeps track of the location for the next instruction to be deal with. Memory address register MAR stores memory location for data or the instruction that need to be fetched from a memory or stored in the memory data register MDR stores data or the instruction fetched from the memory or any data that is to be transferred and stored in the memory. Let's move to the last point. Current instruction register, that is CIR, stores the most recently fetched instruction while it has waiting to be decoded and executed. Let's move to the memory. First point, the computer memory is used to store program, instruction, and data. Moving on, consists of main memory called storage units of a fixed size. Each cell has an address associated with it. Last point, two of the commonly used types of memory are RAM, random access memory, and secondary memory.
So now we will continue with the advantages of von Neumann architecture. So the first point is control unit gets data and instruction in the same way from one memory. And it also simplifies design and development of control. Moving on, data from memory and devices are accessed in the same way. And memory organization is in the hands of programmers. So if you want to change anything, the programmer can change as per her wish. So moving on with the disadvantages of von Neumann architecture. Serial instruction processing does not allow parallel execution of program, and parallel execution later are simulated by operating system. One bus is a bottleneck. That is, only one information can be accessed at the same time. So if you want to do more work at the same time, a single bus cannot do that same work. Moving on, instructions stored in the same memory as the data can be accidentally rewritten by an error in a program. So I hope this video helped you and you learned some new things about von Neumann architecture. So please do like, share, and subscribe our channel.